Hello everyone, I'm going to run through all the different types of factoring that we have done. So this is actually your packet that I gave you. Don't forget on the back we have your factoring checklist. So number one, you always want to look for a greatest common factor. If there are two terms, you're looking for a difference of squares. And then we have three terms where the leading coefficient is 1 and three terms where the leading coefficient is not 1. And if there are four terms, do grouping. So I'm quickly going to run through some examples of all of these problems just so you can kind of hear me go through this again. So I am on page 1. So each of these we are looking for a GCF. So if I look here at 17, this is a binomial. So what is the GCF of 18 and 9? That would be 9. It's the biggest number that goes into 18 and 9. And also for the variables, I have a b and a b squared. So b would be the GCF. This is the opposite of distributing. So 9b times what gives me 18b? That would be 2. 9b times what gives me negative 9b squared, and that would be negative b. So that is how I could factor this binomial. I'll do number 18 now. If I look at my coefficients first, I have 2 and 6. 2 would be the greatest common factor. If you look at your x's, I could get an x squared out of both of them. I could get y to the 5th out of both of them. And now that's my GCF. I say 2x squared y to the 5th times what gives me this first term. So that would be an x and a z. Then I say 2x squared y to the 5th times what would give me the 6x squared y to the 6th. I would need a positive 3 and one more y. And so those are a couple examples for factoring out a GCF. If I move on, if I have some trinomials with a leading coefficient of 1, this is on page 4 here. If number 9 here, since it starts with an n squared, I know that it would have to be an n times an n. It multiplies to give me a positive. That tells me that it's going to be two terms the same. If it adds to give me a negative, they will both be negative. So I want to go through my factor pairs for 1 and 18. It's 1 and 18, 2 and 9, 3 and 6. Because my signs are the same, I'm looking for a sum of 11. So that's going to be 2 and 9. To check it, we always want to do the inners and the outers. So this is negative 2n minus 9n, which is going to be the negative 11n. So that one is factored correctly. The next thing that we did was factor by grouping. So you know that you want to do this method if you start with a polynomial with 4 terms. So looking at number 8, there were 4 terms to start. So I'm going to group the first 2 terms together. I'm going to group the second 2 terms together. And what can I pull out of the first group? It looks like I could pull out an 8, and I would be left with x minus 6. Now in my second group, I'm looking at that, but I want to be left with an x minus 6. So that means I'm going to have to pull out a negative 4. And when I pull out a negative 4, this is going to give me a negative 6, because again, it's the opposite of distributing. Negative 4 times negative 6 is going to give me that positive 24. I also need a, I have to pull out a negative 4z. So if I pull out that negative 4z, then I'm left with a negative 6. And then if I pull a negative 4z out of here, I'm left with a positive x. So x minus 6 in this parentheses, negative 6 plus x in this parentheses, that is actually the exact same thing. So the way that I write this as a final answer would be 8 minus 4z times the quantity x minus 6. I'm going to do one more of those grouping problems. And actually, this one is not completely simplified because there is a GCF of 4. So I can pull it out right now. That means I also could have pulled it out at the very beginning. If you go back and look at the very original problem, you could have pulled a 4 out of every single term. So that one was kind of a tricky one to start off on. If I do number 11, again, there's 4 terms, so I will start by grouping the first 2 terms and grouping the second 2 terms. A GCF for 42 and 98, what's that going to be? 7, does that work? 7 will work. So 7a, and that will give me 6b minus 14. It looks like, I think I could pull more out of there. I think I could pull a 14 out. So if I pull a 14a out, I would be left with 3b minus 7. And then I notice that I already have a 3b minus 7 in my second set of parentheses, but I still need to have a number here, so that's going to be 1 times 3b minus 7. And then I write this as 14a plus 1 times the quantity 3b minus 7. And that one is finished. Another type of factoring we did was when we had a trinomial, but the leading coefficient was not 1. So I'm on page 8 here, and I will look at a few of these different problems here. So this is set 4. 6 is my leading coefficient. So my factor pairs would be 1 and 6, 2 and 3. And so I like to try the two that are closer together first. So I would try a 3v and a 2v. Remember, this is the opposite of foiling. Now, what multiplies to give me a negative number? I know that it has to be 1 positive and 1 negative. So that means that since my signs are different, I'm going to have a difference. So keep in your head that you need a difference of 7. Factor pairs for 3 are 1 and 3. So I'm going to go ahead and write 1 and 3 in here, and then I'm going to check my inners and my outers. This is 2 and 9, and that does give me a difference of 7. If that would not have worked, you would have switched the 1 and the 3, and then you would have tried your outers and inners again. I do have to decide which one's positive and which one's negative. So because I ended with more negatives, that means it's going to be a negative 9 and a positive 2. So negative 9v plus 2v gives me the negative 7v. So I'll look at another one here. 5 is a prime number, so that means it would have to be 5v and v. That's the only possibility. It multiplies to give me a negative, which again means I need 1 positive and 1 negative. But that tells me I'm looking for a difference of 18. So my factor pairs for 8 are 1 and 8, 2 and 4. So one of these numbers is going to have to get multiplied by 5. I can tell that the 4 is going to need to be multiplied by 5 to give me 20. And then the 2 will be multiplied by the 1v. So I have 20v and 2v. I still have to decide which one's positive and negative. I need more positives and less negatives. So I have negative 2v plus 20v. And so that works out correctly. I'm going to go ahead and look at this next one here. To multiply to give me 4, it would have to be 1 and 4 or 2 and 2. I always try the two that are closer together first. Factor pairs for 9 are 1 and 9, 3 and 3. Now, because it multiplies to give me a positive, that tells me that the two signs have to be the same. It adds to give me a negative. So I know that they are both negative, and because the signs are the same, I'm looking for a sum of 15. So I'm just going to try 3 and 3, and I check. This gives me negative 6 and negative 6. That does not add to negative 15. Now, normally I would switch these, but because the 3's are the same number, I don't need to switch them. So the next thing I would try would be 1 and 9. This gives me 2 and 18. That also does not add to 15. Again, I don't need to switch these because both of them are being multiplied by 2. So what that tells me is that it cannot be 2 and 2. It instead would have to be a 4v and a 1v. So then I come back and I would try these again. So if I try 3 and 3, this gives me 3 and 12. Negative 3 and negative 12 does add to negative 15. So now I have that factored. The only other type of factoring that we have is a difference of squares. So this is on page 10. And so if your first term is a perfect square and your second term is a perfect square and there is a minus in the middle, that's called a difference of squares. So what we do we remember that the only way that this happens is by multiplying conjugates. And so conjugates means it's pretty much the same binomial, but the first one would be positive and one would be negative. So you take the square root of the first term, which is a, you take the square root of the second term, which is 7. So my answer would be a plus 7 times the quantity a minus 7. And if I do the same thing on number 12, notice it's a difference of squares. They're both perfect squares. So the square root of a squared is a, the square root of b squared is b, one's a positive, one's a negative. Okay, if I come over here to number 11, again, these are both perfect squares and it is a difference because of that minus sign. So I take the square root and I get 6x plus 7y and also 6x minus 7y. So those are all the different types of factoring that we did. I put a lot of different practice problems for you guys to do. Just remember, always check for a GCF first and then continue going if you can. That's all. Thanks for watching.